Hello students, welcome to the ExamRat. Here you will get your whole course. So do check our website and subscribe our channel, and just link is in description given below. So I am Tanya and I am here to take your mathematics lesson. So in case of any queries or doubts, you can just comment below. You will be getting all your PDF notes with the help of the link given below. So let's start with our unit number 1, number systems, with the chapter number 1, real numbers. So guys, what is real numbers according to you people? So real number is basically the measuring numbers which include all the numbers. Like you can just see here, real numbers, they consist of the rational numbers, they consist of integers, they consist of whole numbers, and they consist of the natural numbers. The rational numbers, they include numbers which are generally in the p by q form. The integers are the numbers which are from minus infinity to plus infinity. Then whole numbers are the numbers starting from 0, and the natural numbers are the numbers starting from the 1. So basically irrational numbers are also the number which we are here to study. So these are about the real number system. You just can have a look on this flow chart, or you can just draw this flow chart in your notebooks. So just you can have a better understanding about the topic. So then we will just start with the whole numbers. So basically whole numbers are the numbers, as you can people see that whole numbers are the numbers which will start from 0 till infinity and so on, whereas the natural numbers are the numbers which generally start from the 1 till infinity. This is all you have to know about the whole numbers and natural numbers, like you have studied in your previous classes too. So there is the real numbers. Main portion is the rational numbers and the irrational numbers. So guys, what is rational numbers? Rational numbers, they are basically the numbers which exist in p by q form, but the q can never be equal to 0, because if the denominator is equal to 0, then the number will be not defined. That is why the q can never be equal to 0. So the examples we can see here for the rational numbers can include 3 by 2, 5 by 2, minus 2 by 1, we can say this. So irrational are the numbers which do not follow this p by q rule. These are known as the irrational numbers, and irrational numbers generally include root 2, root 3, root 5. These are the numbers which are known as the irrational numbers. Now let's just have a look on the integers. So before looking at the integers, we can also have a look on the rational number. The rational number can be expressed or represented by the capital Q, whereas the irrational number, they can be expressed or illustrated by the capital I. Now let's just move forward with the integers. So integers, they are the numbers which are represented by the capital Z. Now the integers can be Z positive or the Z negative. These are the positive integers which generally include from 0 till infinity all the numbers. Then negative integers are the numbers which generally include the number from minus infinity till 0. So this is about the negative integers and the positive integers. So integers, they consist of all the numbers like minus 4, minus 3, 1, 0. Every number, they are known as the integers. So let's just move forward with the decimal expansion. So what is decimal expansion? Basically the decimal expansion of the number, like we can just help you with an example. Just say we divide 10 by 3. Now let's just divide 10 by 3. When we divide 10 by 3, there is a certain decimal expansion we are getting. This is a certain decimal expansion we are getting after dividing some dividend with a particular divisor in a quotient. So basically here 3.333, this is the decimal expansion for the 10 by 3 portion. So the decimal expansion, they can be explained in different ways. Like the decimal expansion, it can be terminating, and it can be non-terminating. Okay, so let's just see what is terminating decimal expansion and the non-terminating decimal expansion. So first we'll go with the terminating decimal expansion. Basically, terminating decimal expansion is a decimal expansion in which the remainder always comes out to be 0. Like, you can have an example, like let's just divide 64 by 8. When we divide 64 by 8, we'll be getting 0 as the remainder. So this is the example of a terminating decimal expansion in which the division generally terminates. Now we're looking forward towards the non-terminating recurring decimal expansion. So let's just know the meaning of this non-terminating thing. This non-terminating thing, that division do not terminates. It means remainder is never equal to 0 in this case. So this is the non-terminating meaning, and recurring itself means repetition. Okay, so basically, for example, if we take 10 divided by 3, the same example we have taken in the another slide. Like this. So we'll just see, then in this case the 3 comes to be repeating and repeating. So in this case we just represent or visualize this 3 with a bar. It means that after the decimal, this 3 is repeating itself up to infinity. This is meaning of the non-terminating recurring decimal expansion. Now we have a look on the non-terminating non-recurring. As I have already told you that non-terminating is the one in which remainder is never 0, and the non-recurring is the one in which there is no repetition takes place. For example, 0.1402100065 and so on. No number is repeating itself. So in this case, this is known as the non-terminating and the non-recurring decimal expansion. Now let's just move forward with another topic. So this is the number line. Okay, so number line, you all people have studied number line somewhere in your previous classes or in your previous standards. So we generally represent number line like this: a straight line with a 0 at the center. All the numbers, they are equally distant from each other. In the right side we generally plot the positive integers, and in the next side we generally plot the positive integers. This is known as the number line. So this is the number line in which we generally plot something if we want to locate some expansions or something. So basically in this chapter in class 9th, you all will be getting to represent the decimal expansion on the number line, and this is known as the successive magnification method. Now, and the second thing you all will be getting learnt is the representation of the irrational number on the number line with the help of a spiral method, and I'll explain both of them in the detail, like what is successive magnification and what is a spiral method to locate a irrational number. Basically, the successive magnification method is generally used. The successive magnification method is generally used to locate the decimals, whereas the spiral method is generally used to locate the irrational numbers. Okay, so let's just look at them in the detail, like what is successive magnification method and all. So successive magnification method, basically the successive magnification method, you all can copy it down in your notebooks because this is very important method and you have not studied this method earlier in your previous classes. So this is a new topic for the class 9th. So basically in the successive magnification, virtual lens is used. Virtual lens is used to locate the decimal expansions. Like, let's just have an example I have used here. Okay, so like you all can see that I have taken the example of locating 3.765 on the number line. Okay, so let's just have a look on it. So 3.765. So first of all, you just have to see that 3.765, it comes between 3 to 4 section of number line. So you just have to draw a number line between 3 and 4. You have to like 3.1, 3.2, 3.3 and so on. Okay, now this is somewhere 3.7 is. Let's just again form a number line like this. Between 3.765 will lie between 3.7 and 3.8. So you will have to draw again a number line, and that number line will be between 3.7 and 3.8. Now again just start with this thing and so on. So you can here see that the 3.765 maybe lies somewhere between 3.76 and 3.77. Then just again draw a number line between 3.76 and 3.77. So somewhere in this between you will get your number. So this is how to locate a decimal expansion, and you can locate any number here. For example, if we take 5.635, so this is a kind of homework for you people. You just have to locate this thing on the number line. Okay, now let's just move forward with another method for representing this. Another method is known as the spiral method of locating the number line. So spiral method of locating the irrational numbers, basically the method which we studied in the previous slide, that was the successive magnification method, and that was used for the decimal expansion. But the spiral method is for irrational numbers, as we all can see. So this is found to be very complicated, but it is not. Basically for this method we just have to use the Pythagoras theorem, which you have used in your classes, in your previous classes. Okay, so let's just take, like, this is a point A, this is point O. Let's just take it a point O. This is point A and this is point B. Now I am drawing this like this. This is point O, this is point A, and this is point B. Okay, now we have to take out, like, we have to just draw root 2 on the number line. So basically this is a 90-degree triangle, so we have to apply a Pythagoras theorem here. So basically in triangle OAB, we are taking it, OB square plus AB square is equal to OA square, right? So in this case, if we want to have OA as the root 2, we'll take OB as 1 centimeter and AB as 1 centimeter. Then we'll get OA square equal to 2. So OA will be equal to root 2 in this case. So this is how you will get the value of root 2. First you have to draw a number line. Here this is 0, this is 1, and this is minus 1. So basically you have to draw a 1 centimeter long line. Then you have to make an 90-degree angle from the number line, and you have to draw another 1 centimeter line. This is 1 centimeter line, and this is also 1 centimeter line, and this is also a 1 centimeter line. Okay, then you just have to open your compass with taking OA as the radius, and you just have to make an arc like this, and the point at which this arc is touching on the number line, this point will give you the value of root 2. For example, the value of root 2 is 1.414 and so on. So like this you will get the value of root 2. Now you can also make it more clear by forming more root on the by the spiral method with the help of this number line. For example, let's just have a look on this picture. Here they have represented root 2, root 3, root 4, root 5, root 6, root 7 and root 8 as well. So basically what they have done, they just have plot those 1 centimeter line here, and they have make a 90-degree angle, and then they have plot a 1 centimeter line BC. Then they just mix both the lines, and then they just open the compass with AC as the radius, and they just put a arc here which is intersecting the number line on this point, and this point is known as the root 2. Like up now you people want to learn how to make root 3, root 4, so it is a very simple method. Now for root 3, like you are taking a triangle COD in this picture. For root 3 you just have to take like root 2 square plus 1 square. It will give you root 3. So basically in this case it means that one side will be, this is the one side, that is OC will be the root 2, and the another side CD will be root 1. So basically look at this picture, like the root 2 you have already constructed. Now you just have to draw a 90-degree angle with the help of a D or with the help of the compass, like forming a 60-degree arc and 120-degree arc, and then intersecting and make a 90-degree arc. Or you can just make a 90-degree angle with the help of a D, and then you can intersect at 1 centimeter. Like this is a 1 centimeter long line, and then you can just join both the ends, like A and D are joined. Then you can have to open your compass, and you have to make an arc which is intersecting on the number line at a particular point, and that particular point will be your that root's value. For example, the value of root 3 is 1.732. This is how you have to construct the square root spiral. So this is all about this. You can just create in this way. Okay, now let's just move forward with our another topic, rationalization. Okay people, so basically rationalization is something very new for you people. So rationalization is like, let's say here is a example I have already given for you people. Okay, so example is like, okay, so example is like 5 plus root 2's rationalization. So for the rationalization, you people just have to like reciprocal of the given term for the rationalization. Basically rationalization, why the rationalization is done? The rationalization is generally done to avoid this root in the denominator portion. Okay, so basically for the 5 plus root 2 we just have to take the reciprocal of this 5 plus root 2 so as to rationalize it. So we are taking the reciprocal, that is 1 upon 5 plus root 2. Then for the rationalized purpose you just have to multiply this whole digit and divide this whole digit with the same number but the opposite sign. It means if the 5 plus root 2 is written here, then you have to multiply and divide this whole unit with 5 minus root 2, taking the opposite signs. So likewise, like I will just explain to you how it is done. Okay, so basically what we have done is we have multiplied and divided with the same number but with the opposite signs. For example, like we are taking 1 upon 5 plus root 2, then we just multiply it with the same number with the opposite signs in between them. So like this we will have to solve it, and this particular thing is solved by the identities you have studied already. The identity is a plus b and a minus b is equal to a square minus b square, and the other identities which you can use here or which will be used in this rationalization is a plus b का whole square and a minus b का whole square. These are the very important identities, and you people just have to know these identities and learn these identities because they are very important. So like this, you can just, so it comes out to be 5 minus root 2 by 23. So this is about the rationalization thing. That's how you can do the rationalization purpose. Okay, you can rationalize anything. You can also rationalize the one which having a numerator and denominator both in the square root. So I'll explain this with the help of the example. Let's just move to the another topic. This is the laws of exponents or the indices. Okay, so basically what is the law of exponents? Generally we call it as the powers or the exponents. So basically there are certain laws for this powers and exponents thing. Okay, now let's just move forward with this thing. Now let's have a look on this. When we have the same bases but with different powers in the multiplication, like this, you all people can see that base here is same, that is both have the a as the base, whereas the power in both the case is different and the sign is of multiplication. Then the base remains 1 and the powers just get added. This is equal to this. In the same case, if we have the same base and the different powers, but in the case of division, then the base will remain this, but the powers will be subtracted from each other. This is these two. Now the power of a power, if we having a base, we having with a particular power and that too with some another power, then we just multiply both the powers like this. Okay, then next is the multiplying the powers with the same exponent. Okay, we have understood when the bases are same, but what happens when the powers are same but the bases are different? Then you can take both the two bases and a common power. Same with the case of division. Now the negative exponents, if we are taking the negative power of something, then it is equal to the reciprocal of the same. For example, if we are taking 2 raised to the power minus 1, it means 1 by 2 raised to the power 1. Okay, power with the exponent 0. If any exponent has the 0 power, then it is always equal to the 1 irrespective of what the a is. It can be 1 raised to the power 0 is equal to 1, 2 raised to the power 0 is equal to 1. Same goes with the division method. This is all about the laws of exponent and their powers. These are the rules on the basis of which you have to solve the problem. Okay, now let's just start with some NCERT questions. So we'll start with it. First we'll go with the decimal expansion. Like we can just solve. If we have to divide 7 by 8, and then you just have to put a decimal over there. Then you just have to solve this thing. Once you have put the decimal, then no need to put the decimal again and again. This is a very basic and easy chapter for the class 9th. So basically we'll get 0.875 as the question. So according to you people, tell me that 0.875 is a which type of decimal expansion as we have studied. Either it is a terminated decimal expansion, or it is a non-terminated decimal expansion. These type of questions are there in the NCERT for the decimal expansion. And another example we can have is divide 1 by 7. You can just divide it like this way. This is like this. So this division will go on. So this is the decimal expansion questions that we have to study in this particular topic. Okay, so we'll get back something very more important. So let's just move to the number line. But for example, now I'll try to plot the number line on the stage. Like we have to plot root 2 on the number line. First we have to we know that for root 2 we have to take 1 centimeter as the base and 1 centimeter as the height. So let's just draw a number line. We'll draw a straight line. We'll put a 0 and the equal distances, like this is a roughly number line I can just show you people. So like this you can just plot a number line. So this is 0 to 1. This is, now you just have to make a 90-degree angle by using a D. Then you can just straight a line and you can put a 1 centimeter arc over the line. You have to join these both lines. Then you have to put a compass here and you have to open it to the length of this OA, and you just have to draw the arc which is intersecting this number line at this point, and this point will be your root 2. This is how to represent a number line for the irrational numbers. Okay, so now we can also show you how to represent the decimal expansions on the number line. You people, you just have to look very carefully. Like we are plotting 5.67 on the number line. So you can see that 5.67 is something lie between 5 to 6. So you just have to draw a number line from 5.1 to 3 with the equal distances. I'm not able to show you the exact number line, but with the help of ruler you can draw the equal number line with the equal distances between each other. So this is now 5.67 will lie somewhere between this 5.67 and 5.7. So you just have to mark this and you have to draw another number line showing these, like 5.61, 5.62, 5.63, 5.64, 5.65, 5.66, 5.67, 5.68, 5.69, and finally 5.7. So basically 5.67, this is the point illustrating the 5.67. Okay, so you will have to mark this point on the number line, and this is how you can easily draw the number line for this number line is for the decimal expansion, and this number line is more importantly known as the successive magnification method of drawing the number line. Now let's just have a look on the more important topic now, that is the rationalization. That's very new to you people. So let's just move forward with the number line. Okay, so guys, let's just move forward with the rationalization. So rationalization, let's just take an example for the rationalization. Like you can take 1 upon 3 plus root 2. Like you have to rationalize this thing, so you just have to multiply and divide this thing with the same numbers but the opposite signs between them. Then you just have to write them. In this we'll write this formula I'm writing again. That formula is very necessary, so do remind that formula, or you can just note it down in your notebooks, so you can just easily remind whenever you need this. And we people are also providing your PDF notes, so you can also have a look on them too. So this will be the answer for this particular question. And if we are given to rationalize, like we are here, we are given that you have to rationalize this thing. So for rationalize this thing, if it is not given in the denominator, then you just have to reciprocal it. If something is given in numerator, then for the rationalization you just have to reciprocal it, and then you have to repeat the same steps as I have taught you in the above question. Just multiply and divide it, but with the opposite signs between them. So this will be the answer, will be 2 plus root 5 divided by minus 1. So this is how you can carry on your rationalization thing. Okay, for rationalization you can also go for, like if you're giving the examples like 2 plus root 3 divided by 2 minus root 3. In that case, you just have to make the opposite signs only from the denominator, not from the numerator. If the square root is given in both the numerator and denominator, then you just need to change the sign for the denominator and then multiply and divide by that particular thing, like this. So you can see we can write it as 2 plus root 3 whole square and 2 square minus root 3 square. I am writing the formula again so you people could easily remind it. A plus b whole square is equal to a square plus b square plus 2ab, and a plus b multiplied by a minus b will be equal to a square minus b square. So we'll just continue with our question. Okay, we'll just apply the formula 2 square plus root 3 square plus 2 multiply root 3 divided by 4 minus 3. So it will be like 4 plus 3 plus 4 root 3, or the answer would be 7 plus 4 root 3. This is how you can also solve the problems having both a numerator and denominator as the square root. Now I'll teach you how to just multiply and divide. Now I'll teach you how to add and subtract the numbers which are generally in the square root. So let's just take the example like 3 plus root 3 multiplied by 2 plus root 2. So in that case, generally a plus b multiplied by c plus d. In that case, we have to just multiply a with both the numbers present and b with also with both the numbers present, like it will look like this. So the similar way we have to do with this rational irrational numbers. We just have to multiply 3 with 2, like 3 multiplied by 2 is equal to 6 plus 3 multiplied by root 2 is 3 root 2. You just have to write like this. Then 2 multiplied by root 3 is 2 root 3 plus, when we multiplied the two irrational numbers, the root is there. Some people did this mistake, they just cut out the root with themselves, but this do not gonna be happen. You just have to just place the root over there and multiply the two terms when the two irrational numbers are given. So it will look like this. This will be the answer for this whole problem. And this thing, they can't be addition or subtraction in between them unless or until they have the similar root among them. For example, if we are taking 2 plus root 2 and then adding it with 3 plus root 2, in that case we can add this thing, like we can just write it as 5 root 2. But if 2 root 2 plus 3 root 3 is given, then we just can't add it. We just can't add it because both of them, they have the different roots with them. So this is how you have to just go and solve the questions. Okay, now we'll start with the now we'll start with the exponents and powers. So let's just look at some NCERT questions for exponents and powers. Okay, so let's just have a look on them. Like for example, first example is, if we are taking 2 as the base with the power 3 by 2 multiplied by 2 as the base, this is a multiplication sign, and just raised to the power 1 by 2. In that case, by applying the rule a raised to the power n multiplied by a raised to the power n is equal to a raised to the power m plus n. We just have to solve this question like 2 raised to the power 3 by 2 plus 1 by 2, which will be equal to 2 raised to the power, and that will be completely equal to 2 raised to the power 2. So the solution for this question is 4. 2 raised to the power 2, that means 4. This is how we can just apply our that basic rules and just clear out, and we'll solve the questions like this. Now let's just have a look on the another example. For example, let's just take an example like 7 raised to the power 1 by 5 divided by 7 raised to the power 1 by 3. So in that case, we'll use this formula, a raised to the power n divided by a raised to the power n is equal to a raised to the power m minus n. So we'll just apply this formula here. 7 raised to the power 1 by 5 minus 1 minus 3. So that will look like this. We'll just take out the LCM for 5 and 3. The answer will be 7 raised to the power minus 2 by 15. And you can also write it as 1 by 7 raised to the power 2 by 15. Okay. This is how you can just solve the problems for the exponents. Let's just move to the another question from NCERT. In case of any doubts or inquiries, you can just comment below. We'll answer your questions for sure. Now I'll tell you something. The powers, if 64 has the power 1 by 2, then basically this 1 by 2 is the power which represent the square root. Similarly, 1 by 3 is the power which symbolizes the cube root. Now let's just take an example. If we are taking 4 raised to the power 1 by 2, then it means 1 by 2 means the square root, and it means square root of 4, so it will be equal to 2. Similarly, if we are taking 27 raised to the power 1 by 3, it means it is the cube root of 27, and it comes out to be 3. This is how the things are done in the case of laws, powers and exponents. Now let's just come to the another question. We'll have a look on another question. Like let's just see 125. It's a homework for you people. You just have to like 125 raised to the power 1 by 3. What does it means and what is the answer of this? You can just easily find out this. Let's just move to the another example. 7 raised to the power 1 by 2 multiplied by 8 raised to the power 1 by 2. In this case, we'll apply the rule a raised to the power m multiply b raised to the power m. In this case, we'll take ab and with the common power m. So in this case too, we'll take 7 multiplied by 8 1 by 2. It means 56 raised to the power 1 by 2, and we can simply write as root 56. Now we can just solve this problem. We can just solve this problem by